Good day again, friends. Here we are back on Peace Online Basic Chemistry. And I say welcome again for another tutorials. Today, we'll be looking at what is matter. From the definition of chemistry, we have already said that chemistry deals with the study of matter. So it is only right that we come to the understanding of what matter is all about. But because this is a very broad subject, we'll be breaking it down, and for these particular tutorials, we'll be doing the introduction. So we ask, what is matter? Matter, simply defined, is anything that has mass and occupies space. Matter is usually built up of smaller particles called atoms, which also have smaller subparticles. And the quantity and the quality of these particles in matter is actually what defines the mass. So we say that the mass of a matter is the quantity indicating the amount of these particles embedded in that matter, in that object. That is the quantity of matter in an object. And then matter also finds a location. It's also placed in a direction and is also found in a particular position. And there we talk about space. It occupies space. So when we give example of what matter is, we talk about everything we observe around us. Even you, yourself, you are made up of matter. So next we'll be looking at the phases of matter. Having understood that matter is everything observable around us, we can conclusively say that matter occurs in three basic states called phases. When we talk about these phases, we're talking about the solid phase, we're talking about the liquid phase, we're talking about the gaseous phase. For the solid phase, it is relatively ordered. It is a three-dimensional structure of matter. It has its own density and shape, even if not confined. That is not put in a container. We have examples like your wood, most metal around you like the iron, the rocks, your glass, your ice water, your table sugar, your salt. These have definite shapes you can easily identify, and they are relatively rigid. They have a definite volume, and their intermolecular forces are high, keeping the shape. Secondly, we look at the liquid phase. This is a middle point between the solid and the gas. In this state, you have the liquid having a definite volume but has no definite shape. It has to be shaped by the containing vessel, the vessel in which it is poured into, the vessel carrying it. We have examples, common examples around us like the water you drink, your oil, and the blood. It's not rigid, but rather it flows, usually from higher levels to lower levels. And in this case, the intermolecular forces are not as strong as the solid forces. Lastly, we talk about the gaseous phases. It is the state of matter which neither has a definite shape nor a definite volume. It has relatively non-existent intermolecular forces. It's not rigid at all, but rather it possesses high molecular kinetic or mobile energy that keeps its molecules far apart. There is no definite volume, except it is put in a container. it takes the volume of the container. It has no definite shape. It takes the shape of the container. So, we can conclude that intermolecular forces decreases from solid to gases, while kinetic energy increases from solid to gases. Hence, introduction of heat into the solid would lead to a change of state from solid to liquid, or even sometimes directly to the gaseous state. And when the liquid absorbs kinetic energy from heat, it also changes its state to the gaseous. And that leads us to an additional phase that is not commonly discussed, but is very important in science. And it is called the plasma phase or superheated matter. This is the phase that occurs when the gases are applied more heat energy. In this case, the atoms get really hot and electrons are ripped off of the nucleus of these atoms. We are going to be learning about atoms later on, but I just want you to have this information. And this causes a pool of ionized particles. And in fact, the universe is comprised of 99% of plasma matter. We find this in the sun, we find it in the star, we find it in lightning. In fact, it is plasma matter that makes life living on Earth a possibility. Having talked about the phases that matter exhibits in nature, we now want to look at the characteristics of matter, its properties, or its identity. These properties are what characterizes matter and differentiates them one from the other. Like sugar could be characterized physically as a solid with a sweet taste and a crystalline structure. And a similar solid like it, which is the common salt we take at home, can also be characterized as white, just like sugar, crystalline, just like sugar, but the savory taste of salt differentiates it from sugar. Both are soluble in water, but we can differentiate it physically by the taste. And this also applies to every matter. Matter has its unique properties, and this is the identity that particular matter goes with. And these properties affect the reactions, changes that this matter undergoes. Basically, these properties are divided into two and are usually associated with the kind of reactions or changes that they induce in that matter. First is the physical property. The physical property of matter is associated with physical changes. We're going to be talking about the changes of matter very soon. And we also have the chemical properties, and these chemical properties are associated with the chemical changes. Talking about changes of matter, we see that it is a very important part in chemistry, because chemistry deals with the principles governing the changes that matter undergoes. In relation to the properties just discussed, we can conclude that matter undergoes two basic types of changes, which are the physical and the chemical changes. From the table on your slide, you'll be looking at the comparison, or rather contrast, between the physical change and the chemical change. Summarily, we say that physical change is that particular change that matter undergoes which is easily reversible and in which no new substance is formed. While on the other hand, a chemical change is not usually reversible, and in all cases, you have new substances formed. What are the examples? In our surrounding, all these changes occur. Like for the physical change, when you dip your salt in water, it dissolves, or your sugar in water, it dissolves. This is a physical change because no new substance is formed and it is easily reversible. The salt can be gotten out from the water and the sugar by evaporation. We also have magnetization of iron filings. We can demagnetize them as well and no new substance is formed. But when we talk about chemical changes, we talk about a complete reaction that brings up a new structure, a new matter, a new identity entirely. Just like when you take up wood and you burn them in fire, you find ash, gaseous air giving off, and the ash cannot be returned back to the wood. You cannot get back the wood. You obtain ash which you cannot reverse back to the wood which was burnt. Another example is the cooking of an egg. When you cook an egg, the action is irreversible. The boiled egg cannot return back to its original state. Talking about these changes, they are associated with the properties of matter. The dissolution of that solid in water or any other solvent defines its solubility. And also, we talk about the melting point of solids, the freezing point of liquids, and we also talk about the rusting of iron, a chemical property of iron metal, the magnetization of iron. All these are associated with the changes they undergo. Lastly, to end these tutorials for today, we'll be looking at the classification of matter. In major terms, matter can be classified into 3 classes. We have the elements, the compounds, and mixtures. These elements and compounds are bound chemically and cannot be separated by physical methods. Hence, they are termed as pure. But when there is a case of any of these, either the element or the compound, combining physically with any other substance, which we term as impurities, we obtain mixtures. And because they are bound physically, they are separated by physical methods using any of their physical properties that has been identified. Looking at the slide in front of you, it shows a chart of the building block of matter, and in further tutorials, we'll be looking at them in depth. But today, as we conclude at this point, saying thank you for listening, thank you for watching the previous tutorials, and thank you for sharing your time with us. I would love you to like, share, and make your comments as well so that we can improve in these tutorials as well as reach more people. Thank you. Bye. See you next time.